what we're going to do is talk a little bit about our product we have to offer. Got a demonstration set up here to show you exactly how the material works. We're going to talk about your existing insulation, how it works, and how adding a radiant barrier to it can dramatically increase its efficiency. We have made this video as brief as possible. The main product we're going to be talking about here today is radiant barrier. The product is 99% pure aluminum, has a mylar type poly in the center to give it its tensile strength. It's also a perforated barrier, so it is a breathing barrier, meets all the building codes throughout the United States. We either put it on top of your existing insulation or we can put it to the rafters. It really depends on where you live and how you use your attic space as to which application would be best for you. For those of you who have never seen a radiant barrier presentation before, let me show you what we've got here. I've got two 250 watt infrared heat bulbs, two pieces of R13 fiberglass insulation, and 4 thermometers. Now if you notice, the temperatures of the thermometers are all a little bit different. We've tried several times to get this video exactly right, and unfortunately we don't have enough time to let the heat lamps and everything cool down to the exact room temperature before we start again. So hopefully this time we'll be able to get it right. Now what's going to happen, I'm going to set this over here on this side. We'll just start out over here. As you see, I'm placing the probe on top. Turn both these heat lamps on. Now what's going to happen is the side with the heat lamp, the side with the barrier is going to hold constant within a few degrees. It might move as much as 10-15 degrees. Now the side without the barrier, as soon as this heat lamp heats up, that heat's going to absorb through the insulation and that thermometer is going to move. I think one of the problems that we all have in common is heat. There's too much of it in the summer, of course not enough of it in the winter. And the challenge is to prevent the heat from entering in a home in the summer and escaping during the winter. And that's exactly what a radiant barrier will do. There's 3 different ways that heat transfers. Conductive heat, which is direct heat flow from one source touching another. Convection, which is simply heat rising. And radiant heat, which is a movement of heat from a warm space to a cool space. Up to 90% of the heat we gain in the summertime is radiant heat. Up to 75% of the heat we lose in the wintertime is radiant heat. So radiant energy is the biggest factor affecting our utility bills. Unfortunately, conventional insulation, whether fiberglass, fiber wool, rock wool, or cellulose, are limited to working with conductive and convective heat only. That's it. Conventional insulation works on an R value. An R value measures the resistance to heat flow once the product has already absorbed the heat. So conventional insulation does not stop or block heat. It simply slows the heat transfer down. A radiant barrier, on the other hand, works by reflecting the heat initially, unlike slowing heat transfer down like conventional insulation. Basically what happens in the summertime, as your attic heats up, that heat absorbs through the insulation, through the sheetrock, and into your home. That's what your air conditioning unit is working against. When you install a radiant barrier in the attic, it reflects the heat up, your ventilation pulls the heat out. Now all of the testing on the radiant barrier, whether the Oak Ridge National Laboratory, the Tennessee Valley Authority, the University of Mississippi, all of them show that radiant barrier works in conjunction with ventilation. Simply put, the better your ventilation, the better the product will perform. There are some homes that will require additional ventilation for the product to work properly. Now as you see what's happening over here, you can take a look at the thermometers on top. They've both gone up. If you take a look at the thermometers below the insulation, you'll see that the side with the barrier has held constant within a few degrees. Now the side without the barrier is starting to go up. It's no wonder why NASA nicknamed conventional insulation and radiant barrier working together as a team a super insulation. And this is exactly what it will do for the insulation in your home. When you can reflect the heat initially, you don't have to deal with the other forms of it. So you have less heat transferring into your house, taking the load off the air conditioning unit, prolonging the life and the efficiency of it, and because it runs less and cycles less, use less electricity and your bills come down. Now I realize that this is a summertime presentation, but in the wintertime, as we heat our house up, the heat absorbs through the ceiling, through the insulation, and emits it in the night air. Installing a radiant barrier on top of the existing insulation reflects the heat down into the home where it belongs. As many of you know, NASA first developed radiant barrier to deal with the extreme temperatures in space. Today, however, you'll find radiant barrier in thousands of applications, ranging from simple products such as thermal bags, insulated coolers, and thermal blankets, to more complex applications like airplanes, trains, computers, cryogenics, missile testing, and every automobile on the road today. Radiant barrier is a proven technology. And with the rising cost of utilities, it's no wonder why so many people are making the decision to go with radiant barrier.